Greetings everyone. This is Navjot, your cosmic guide for the day. Today, we embark on a journey back in time, to the very birth of the universe. Our tale begins with a theory, the Big Bang Theory. Imagine the universe as we know it. All the stars, galaxies, and vast cosmic voids initially compressed into an incredibly hot, dense point, smaller than a single atom. This is the starting point of the Big Bang Theory, the prevailing cosmological model for the observable universe. Now, what is the Big Bang Theory, you might ask? Well, it's not just a popular television show, it's a scientific explanation, a narrative of creation, which states that our universe began as a hot, dense state approximately 13.8 billion years ago. This was not a typical explosion, as the name might suggest, but an expansion. An expansion so swift and violent that it created time and space as we know it. This unimaginably hot, dense point began to expand rapidly, a process we refer to as cosmic inflation. As the universe expanded, it cooled. The energy present within it began to transform into subatomic particles, then atoms. These atoms eventually formed the stars and galaxies we see today. But that's a story for another scene. The Big Bang Theory, while still a theory, is widely accepted among scientists as it is the best explanation we have for the existence of the observable universe. It's supported by a multitude of scientific evidence, from the cosmic microwave background radiation to the large-scale structure of the universe. However, like any good scientific theory, the Big Bang Theory continues to be tested and refined as we gather more data from our cosmic surroundings. It's a testament to our never-ending quest for understanding, a testament to our curiosity. This rapid expansion, known as the Big Bang, is how our universe sprang into existence about 13.8 billion years ago. But hold on to your seats, as our journey has just begun. Stay tuned as we delve deeper into the mysteries of the cosmos. After the Big Bang, the universe cooled down and the first stars were born. Let's dive into this celestial journey. Picture a universe that's a mere 300,000 years old. It's a hot, dense sea of particles, primarily hydrogen and helium, with a sprinkle of lithium and deuterium. As the universe expanded, it cooled. This cooling allowed these particles to come together, forming neutral atoms. This era, known as the era of recombination, marked the end of the universe's opaque phase and the birth of the cosmic dark ages. Now, this cosmic darkness wasn't eternal. Gravity, that unyielding cosmic sculptor, began to pull these neutral atoms together. The denser regions attracted more matter, and as this matter collapsed under its own gravity, it heated up, eventually reaching temperatures hot enough for nuclear fusion. This fusion ignited the first stars, piercing the cosmic darkness with their light. This process wasn't a quick one, though. It took hundreds of millions of years for these first stars to form. These pioneers of the cosmos weren't like the stars we see today. They were much more massive, up to 100 times the mass of our sun, and they burned through their nuclear fuel at an astonishing pace. Their short, brilliant lives ended in spectacular supernova explosions, scattering heavier elements like carbon, oxygen, and iron into the surrounding space. These elements, the ashes of the first stars, would eventually come together to form a new generation of stars, stars like our sun. And around these stars, planets would form, creating the diverse cosmic landscape we see today. These first stars, then, were the cosmic alchemists, transforming the simple elements formed in the Big Bang into the complex elements that make up the world around us. From the iron in our blood to the oxygen we breathe, we owe it all to these celestial pioneers. These first stars, forged from the raw materials of the universe, were the building blocks for everything that came after. From the first stars, galaxies began to form. Each galaxy is a swirling, cosmic whirlpool of stars, gas, and dust, bound together by the mysterious force we call gravity. Picture an enormous city of stars, each one a bustling hub of activity where the dance of celestial bodies plays out over millions of years. The formation of galaxies is a cosmic story of epic proportions. It begins with the first stars. These initial celestial bodies were not solitary. Rather, they were the seeds around which galaxies would grow. Their gravitational pull began to attract nearby gas and dust, creating a dense region in the otherwise sparse universe. But there's another character in this cosmic drama: dark matter. Invisible and undetectable, dark matter does not interact with light or any other form of electromagnetic radiation. Yet it exerts a gravitational pull, just like ordinary matter. It is thought to make up about 85% of the matter in the universe, and it played a crucial role in the formation of galaxies. The first stars and the surrounding dark matter created gravitational wells, pulling in more gas and dust. Over time, these dense regions grew larger and larger, eventually forming galaxies. The process was not quick or smooth, but a slow and chaotic dance that took millions of years. These galaxies are not just collections of stars. They are complex systems with gas and dust forming intricate structures within them. Some galaxies have beautiful spiral arms, others are elliptical or irregular in shape. Each one is unique, a product of its own cosmic journey. And within these galaxies, new stars continue to form, born from the gas and dust that fills the space between existing stars. These stars may eventually gather their own dust and gas, creating planetary systems and perhaps somewhere out there, life. These galaxies, each home to millions or even billions of stars, are the grand structures of the universe. They are testament to the power of gravity and the mystery of dark matter, revealing a universe that is complex, dynamic, and endlessly fascinating. Within these galaxies, planets began to form. The process of planet formation, also known as accretion, is a fascinating journey that begins with the most basic elements of the universe. Imagine a young star, fresh from its own fiery birth, surrounded by a swirling disk of dust and gas. This is the environment in which planets are born. Initially, these particles of dust and gas are spread out, floating aimlessly in the vastness of space. But as these particles collide and stick together, they begin to form larger and larger clumps. These clumps, or planetesimals, are the building blocks of planets. The process doesn't stop there. As these planetesimals continue to collide and merge, they grow in size, gradually forming protoplanets. These protoplanets are still not quite planets as we know them, but they're getting closer. They start to heat up and become molten as they grow in size and the force of gravity works on them. As these molten protoplanets cool down, they start to differentiate or separate into layers. Heavy materials sink to the center, forming a core, while lighter materials rise to the surface, forming a crust. This process, known as planetary differentiation, is what gives a planet its structure, with a dense core, a mantle, and a crust. Finally, over millions and millions of years, these protoplanets cool down, their surfaces solidify, and they become planets. They may develop atmospheres, perhaps even oceans, and possibly, under just the right conditions, life. This process of planet formation is ongoing. Right now, in far-off corners of the universe, new planets are being born. Some may be similar to our own Earth, with the potential to harbor life. Others may be gas giants like Jupiter or ice giants like Neptune. And so, from the dust and gas surrounding stars, planets like our own Earth were born. Through a process that spans millions of years, the universe continually creates and recreates itself, turning stardust into planets and planets into homes for life as we know it. We've journeyed from the birth of the universe to the formation of planets. Let's take a moment to reflect on the incredible voyage we've undertaken. Our journey started with the Big Bang, the universe's fiery birth. This event, occurring about 14 billion years ago, was the catalyst for all existence. In the wake of the Big Bang, the universe was a hot, dense soup of particles rapidly expanding and cooling. This period was a cacophony of creation, an orchestra of cosmic proportions. Next, we delved into the formation of the first stars. These celestial giants were born from the primordial hydrogen and helium, the universe's first elements. They ignited, shining brightly against the backdrop of the dark cosmos. The life and death of these stars seeded the universe with heavier elements, setting the stage for the next act in our cosmic drama. Then, we explored the birth of galaxies, colossal structures composed of billions of stars. These galaxies are the universe's cities, each with its own unique story. The Milky Way, our galactic home, is just one of countless galaxies in the vast ocean of the cosmos. We journeyed to the formation of planets, intricate and diverse worlds carved from cosmic dust and gas. Our own Earth, with its unique conditions, is a testament to the universe's ability to create life out of chaos. As we reflect on these topics, let's ponder some unknown facts about the universe and planets. Did you know that the universe is flat, or that there are potentially more planets than stars in the cosmos? Or that the Earth's rotation is gradually slowing down, making our days fractionally longer each century? Our voyage through the cosmos has been a reminder of our place in the universe. We're not separate from the cosmos, but a part of it. We are children of the stars, born from the cosmic dust of the universe's early days. Remember, we are all made of star stuff, born from the cosmic dust of the universe's early days. Until next time, this is Navjot, signing off.